Hello friends, today I am going to tell you about group theory. In the group theory, we actually study about the 3D representation of molecule and the symmetry around it. We can see that everywhere or everything whatever we see around us, it has a symmetry. So let's start with group theory. So what is the group theory actually? It is the mathematical study of symmetry which is called group theory. Okay. So in the group theory we will study about elements of symmetry. So there are 5 elements of symmetry. These are axis of symmetry, plane of symmetry, improper axis of symmetry, center of symmetry and identity. Okay, so I'm going to tell you about axis of symmetry. This is what is the axis of symmetry? In which we pass an imaginary axis, okay, and rotate our molecule around it. You can see there, like this one is hydrogen, this one is hydrogen, this one is oxygen, okay, this is our water molecule. So what we are going to do here, it is a line, or we can say it is an axis passing through these molecule, okay, passing through this molecule and dividing it both, this hydrogen and this hydrogen, okay. So what we will do, we will rotate it from this axis, okay. This, suppose this one is our hydrogen 1 and this one is our hydrogen 2, okay. I have already written it over here. I will understand, let you know about this. So this one is hydrogen, this one is oxygen and this one is hydrogen, okay. So this is our initial stage. So we are going to rotate it by 180 degree, okay. It is so that simple that how, from which angle we have to rotate it. So suppose this is our central atom, oxygen, and suppose we have 2 elements surrounding this, okay, 1 or 2. So we will rotate it by 180 degree. We will divide it with 2. We have 2 elements around this, so we will divide it with 2. So this is our angle. We have to rotate it with this angle, okay. Suppose we have, this is center atom and we have 3 elements around this, so we will rotate it by 360 by 3, so it will become 120 degree, okay. So you have to rotate it by, so just divide it with the surrounding atoms, just divide 360 degree by the surrounding atoms, okay. Here I told you about that how we will calculate the angle in by which we have to rotate this our molecule, okay. So here we were rotating this water molecule, so we have rotated it with 180 degree, okay. When we will rotate it 180 degree, then what will happen, we will rotate it like this, then this hydrogen will go on that side and this hydrogen will go on that side, okay. So we will get this position, this hydrogen, this one hydrogen is on this side and this hydrogen is on this side, it is rotated. So this stage is called equivalent stage, okay. Then we will again rotate it with 180 degree and then we will get this hydrogen on this side and this hydrogen 2 on that side. This is our initial molecule which I have taken. So we will say that it is identical to this one, okay. This initial is identical to this one. So how many operations we have performed? We have performed only one operation, because we have only performed one operation. How can we say that? This one was initial and this one was equivalent. So we have done only one operation, because after performing this operation, that one when we have rotated 180 degree again, then we will get the identical. So it is not an operation, we will not calculate it in operation, because after performing this operation we have got the initial molecule, the identical molecule. So we have done only one operation over here, okay. So I have already tell you about number of operation. So I'm just giving you example of ammonia. This one is nitrogen. We have 3 hydrogen around this. So we have calculated our angle. How we have calculated? We have nitrogen and we have surrounding atom. Number of surrounding atom is 3. So we will divide 360 degree by 3. So we will get 120 degree. Okay. So this is our axis, this axis, and we will rotate it by 120 degree. Okay. So in this case, and you can see we have 3 molecules. So its axis is C3 axis. Okay. C3 axis. So here we are rotating it 120 degree. So what will happen when we will rotate it 120 degree? Then this hydrogen will go on that side, this hydrogen will go on that side, and this will go on that side. Okay. So here you can see that hydrogen 2 has gone on the place of hydrogen 3. Hydrogen 3 was gone on the place of hydrogen 1, and hydrogen 1 was gone on the place of hydrogen 2. So we have performed here one operation. Okay. This is an equivalent structure. This is not, we cannot say this is an identical structure. Okay. So now our second, this one is C32. We are going to perform second operation. So what will happen on this operation? Here this hydrogen 1 will go on the place of hydrogen 2, hydrogen 2 will go on the place of hydrogen 3, and hydrogen 3 will go on the place of hydrogen 1. Okay. So here it is. You can see, as I told you, yeah, this one is hydrogen 2, hydrogen 1, and hydrogen this was that structure, I'm sorry. Yeah, you can see that hydrogen 1 is gone on the place of hydrogen 2 here, and hydrogen 2 is gone on the place of hydrogen 3 here, hydrogen 3 is gone on the place of hydrogen. So now we will perform this operation. We will again rotate this molecule by 120 degree. Okay. Then after performing this operation, we will get our identical molecule. As you can see that hydrogen 2 is on left side, and in this case also hydrogen 2 is on left side, hydrogen 3 is on right side, hydrogen 3 is also is on that case it is on right side, and hydrogen 1 is on middle, and hydrogen 1 is on middle in that case also. So this one is our identical structure. Okay. So the last step, this one, from when we are rotating this one into this one, then this will C33 is equals to, this will become identity. Okay. We will denote identity by E. This will become identity. So we will not calculate it in operation, because after performing this we have get our initial molecule. So we will not calculate it this step in operation. So we have done only 2 operations, this one and this one. As you can see, I have written over here. Order of axis is n is equals to 360 by 120. This is equals to 3. If we have to calculate order of axis, then you can just divide 360 degree by 120. So this one is C3, and number of operations are 2, because C33 is identity. Okay. So in my next video, I am going to tell about how can we see C2 axis or C3 axis in any molecule, and after that I will tell you about point groups. Okay, so keep watching my videos, and please don't forget like and subscribe my videos. Thank you.